Okay, so on number 26, we're going to find the length of a parametrically defined curve. So we have our question that they gave us here. And on page 664, you have the formula for the length of a parametric curve. So using this function, or this definition, your function f is your x. So that's t cubed. So we take the first derivative of that with respect to t, and we get 3t squared. And then I've also found the derivative of g, which is your y. So the derivative of 3 halves t squared is equal to 3t. And we need to take those values and plug them into our formula. So we get 3t squared, the quantity squared, plus 3t, the quantity squared. So doing a little bit of algebra here, that simplifies down to 3t times the square root of t squared plus 1. Now we need to integrate this, so to do that, I think that we can use u substitution. If we let u equal t squared plus 1, then du will equal 2t dt, and that means that t dt equals a half du. I'm going to go ahead and switch my area of integration over, so if I know that t was equal to 0, then u will equal 0 squared plus 1, so u is 1, and if t equals square root of 3, so I'm plugging in my 0 and my square root of 3, then u will be square root of 3 squared plus 1. So u will be 3 plus 1, which is 4. So my length integral then becomes not 0 to square root of 3, but 1 to 4. And then I have my constant of 3. I'm just going to let it hang out here. Now, my t dt, this piece of it, is equal to a half du. So I'm going to plug in a half du, leave some space in there, and then the square root of t squared plus 1, I know that t squared plus 1 is u, so I will have square root of u, and then we need to integrate that. So our constant then becomes 3 halves, and then if we integrate u to the 1 half, add 1 to your power, you get 3 halves with 2/3 in front, which is convenient. And we're going to integrate that from 1 to 4. So we have u to the 3 halves from 1 to 4. So we have 4 to the 3 halves minus 1 to the 3 halves. Now 4 to the 3 halves, 4 is 2 squared. If you raise that to the 3 halves, then the 2's on the powers will cancel then. So you have 2 to the 3rd, which is 8, and then minus 1. So we get 7.